Hi folks, and welcome back to Math with Captain Rod. I'm making this to be example number 2, I guess, of a series on graphing parabolas. So we're going to take a look at this function, y equals minus x squared plus 4x plus 3. We're going to try to find the vertex and plot it, and what we're going to do is we're going to use this form of a parabola. So again, written in this form, a times x minus h squared, the quantity squared plus k. The vertex is at the point hk, so the idea is to try to make this look like this. And what you do is you focus on this stuff. In fact, I'm going to take that 3 and just kind of move it over here now. Now, before we get started, you notice that this is a minus x squared. Whenever you're completing the square, you want this to be a 1. So the first thing you typically do is do whatever mathematical operation you have to get this to be a 1. What I'm going to do here is start this by multiplying everything by negative 1. So the next line, negative y equals x squared minus 4x. Leave my space, and that'll become a minus 3. Okay. Had this been like a negative 1/2, we would multiply by negative 2 to get a 1 here. Had this been, say, negative 3, you would divide by negative 3 to get a 1 here. You do whatever you have to make this thing a 1, and you have to do everything. Okay. All right. Now you tunnel vision on this, and the idea is we want to make this equal to x minus something, the quantity squared. Now it's minus because of this thing. Had this been plus, here we'd put a plus. Whatever number goes here is always going to be half of this, so this has to be a 2. Because when you FOIL this, the outer and inner terms have to give you the 4. Now remember how FOIL works. First, outer, inner, last. The last multiplication is going to be plus 4, and we look right here and go, well, there's not a plus 4 there. Easy fix. We'll just go plus 4. Now, when you do this, however, we have to maintain equality. To do that, we can either add 4 to the left or subtract 4 on the right. I'll go ahead and just put minus 4 over here so that this pair right here, we have not changed anything. These still add to 0. Next line now. So we have minus y equals. This now, we have designed it to equal x minus 2, the quantity squared. Right? That's where the term completing the square comes from. We took this and we turned it into a perfect square. And then negative 3 minus 4 is minus 7. Now, to make this look just like this, the last thing we just have to do is put this minus sign over on the right by either multiplying by minus 1 or dividing, depending on which you like. That'll become a plus 7. All right, so now we know that this thing opens down. I guess we already knew that looking here, but the vertex is the point 2, 7. Right, remember, it's x minus 2 compared to x minus h. H would be 2. And then 7 and 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. There's the vertex. Intercepts are usually a nice thing to have. The x-intercepts when we graph a parabola. Why don't we go ahead and graph those? We can do that by setting y equal to 0 and solving for x. There's several locations we can do that, really. This line, or really any of these, but let's just take this one here. Let's rewrite this. 0 equals minus x minus 2 squared plus 7. Moving the 7 over, we would have to subtract 7. Divide the minus out. Now, when we square root both sides, there are 2 possibilities. Possibility number 1, x minus 2 equals root 7. Right, so if this were equal to square root 7 squared, you'd get 7. The other possibility is that x minus 2 could equal minus root 7, because right, if this thing here were negative root 7 and you squared it, you would also get 7. Solving the first one for x is going to equal 2 plus root 7. Solving the second one for x is going to equal 2 minus root 7. And if you don't mind, I'm just going to get decimals for these values. If you just give me a moment here. 2.6. So this one right here is approximately, I'm getting 2.65 for that, so this is approximately 4.6. And then This one is, I think, negative 0.64. Just check that real quick. Yeah, actually negative 0.65. I guess that rounds to a 5. Whoops. Sorry about that. All right. So our intercepts now. They're not nice, easy, perfect intercepts, but that's okay. Okay, so 4.60. So 1, 2, 3, 4. Now 4.5, and maybe just a tiny little bit more. 4.6. That's good enough. Okay, negative 0.65. So here's 0. Minus 1 would be here. Minus 0.65 is just a little more than halfway. It's probably enough to sketch it. Again, this is just meant to be a sketch. Oh, you know what? We can do better than that. You know, one more point. Let's grab one more. Let's get the y-axis too. I think that'll help me with my sketch. That's easy to get because x is equal to 0 on the y-axis. So looking right here, if you set x equal to 0, that's 0, 0, and then 3. So 0, 1, 2, 3. Now parabolas, remember, are symmetric. So this point here, let's see, is 2 to the left and 3 up. There's got to be another point, 2 to the right. There's a couple more points here. That'll help me sketch this. And something like this. Close enough. This parabola is symmetric about this line. That's what allowed me to find that point. This line is going to be x equals 2. And there we have it. I think we're good here. We've got our parabola sketched. Not too much more to say here. Start by writing out this form of a parabola. Take your function and complete the square on this stuff to make it look like this. Pick out the vertex, pop it on the graph. Set this equal to 0 to find your intercepts. Put those on the graph. Sketch it. And hope that this was enjoyable. Have a great day.